So we're going to do lesson 4 now, writing products as sums and sums as products. What I need you to be able to do after this lesson is use an area model to write products as sums and sums as products. I need you to use the fact that the opposite of a number is the same as multiplying by -1 to write the opposite of a sum in standard form. Remember standard form, that definition? I need you to be able to recognize that when you rewrite an expression in a different form, it can kind of shed light on the problem and how the quantities in the problem are related. So first we're going to look at example 1. Notice these types of problems versus these. You're going to write an equivalent expression using the distributive property for the first 4 problems. And then you're going to factor out a common factor in the bottom 4 problems. So that means let's hand out this multiplication of 2 to x and then 2 to 5. 2 to x, then 2 to 5 gives us 2 times x is 2x, and 2 times 5 gives us 10. Do it again. 3 times x is 3x, and 3 times 4 gives us 12. 6 times x gives us 6x, and 6 times 1 gives us 6. 7 times x gives us 7x, and 7 times -3 gives us -21. Or -21, they mean the same thing. To -21 is the same thing as add -21. That's why it doesn't matter which way you read it. Okay, now let's do the opposite. Let's try to figure out what factor 5x plus 30 have in common. Well, think about your factors of 5, think about your factors of 30. They both have a 5 in common, so we would pull out a 5, and you're going to ask yourself, 5 times what gives you 5x? Well, 5 times x gives you 5x. 5 times what gives you 30? 5 times 6 gives you 30. So that is the factored expression to 5x plus 30, which is in the standard form. Now let's do the same thing here. What does 8x plus 8 have in common? They both have 8 in common. 8 times what gives me 8x? 8 times x gives me 8x. And 8 times what gives me 8? 1. So I write plus 1. 3x minus 12. They both have a 3 in common. 3 times what gives me 3x? X. And 3 times what gives me -12? Well, that's -4. You could have written plus -4 and still gotten the same answer. Last one, 15x and 20. They both have 5 in common. 5 times what gives me 15x? 3x. 5 times what gives me 20? 4. So here we did the opposite of the distributive, or we did the distributive property to write an equivalent expression. Here we factored the expression to write an equivalent expression. So I would like you to try A through D here, doing the same thing. Rewrite the expression as a product of 2 factors. So pull out the factor that they have in common. If you would pause the video and do that, that would be wonderful. The more you try on your own, the better you're going to get at these. So now that you've tried them on your own, what does 72 and 8 have in common? They both have an 8. So 8 times what gives you 72t? 8 times 9t gives you 72t. 8 times what gives you 8? 1. 55a plus 11. They both have an 11 in common. 11 times what gives you 55a? 11 times 5a gives you 55a. 11 times what gives you 11? 1. 36 and 72. 36 and 72 both have, they have a lot of things in common, but you want to always pull out the greatest common factor, the GCF. Otherwise, you can keep one simplifying it down. So the greatest common factor that 36 and 72 have in common are 36. So 36 times what gives me 36z? Well, that's Z. And 36 times what gives me 72? That's 2. 144 and negative 15, they both have a 3 in common. 3 times what gives me 144Q? Well, that's 48Q. And 3 times what gives me negative 15? Negative 5. 3R plus 3S. They both have a 3 in common. 3 times what gives me 3R? R. And 3 times what gives me 3S? S. Okay, so we rewrote equivalent expressions there as a product of 2 factors. In example 2, it says let the variables x and y stand for positive integers, and let 2x, 12y, and 8 represent the area of the 3 regions in the array. Determine the length and width of each rectangle if the width is the same for each rectangle. So when it says if they're the same, then we need to figure out what 2, 12, and 8 have in common. Well, they both have a 2 in common. So 2 times what gives me 2x? 2 times x gives me 2x. 2 times what gives me 12y? 2 times 6y gives me 12y. And 2 times what gives me 8? And that's 4. So the length and the width of each rectangle is given here. We have a rectangle that is 2 by x plus 6y plus 4. So that means the greatest common factor between all of these is 2. So here is the expression as a sum, because sum means to add, 2x plus 12y plus 8. And here is the expression as a product of 2 factors. 2 times, because product means to multiply, 2 times x plus 6y plus 4. These two things mean the same thing. They are equivalent expressions to one another. Let's try exercise 2. Write the product and the sum of the expressions as being represented in the rectangular array. This is just like what we did, so if you would pause and do it, that would be great. So if we're going to write it as a sum, then all we have to do is add those 3 together. If we're going to write it as a product, that means we have to multiply. And to get these answers, we need to kind of think of it as length times width. So 2 times 12d plus 4e plus 3. This is it as a sum. This is it as a product. Because we're adding here, we're multiplying there. Let's do the other way now. It says factor 48j plus 60k plus 24 by finding the greatest common factor of the terms. So what do 48, 60, and 24 have in common? Well, they have a 2 in common. They have a 6 in common. The greatest common factor, though, what do you think? It's 12. So you're going to ask yourself for each one of these terms in the problem, what do you do to 12 to get there? 12 times what gives me 48j? 12 times 4j gives me 48j. 12 times what gives me 60k. 12 times 5k gives me 60k. And 12 times 2 gives me that 24. So this is the factored form of that expression. They have the same value, they're just written in different ways. For exercise 3, I think that you should try these. Well, let's do some of them together, and then you can try a few by yourself. For each expression, write the sum as a product of 2 factors. Emphasize the importance of the distributive property, and use various equivalent expressions to justify equivalency. So this is the sum of 2 factors. What do these two have in common? They both have a 3 in common. So that's what we're going to pull out. 3 times what would give me 3 times 2? Well, 3 times 2 would give me 2 times 3. And 3 times what would give me 5 times 3? 3 times 5 would give me 5 times 3. So these two are said to be equivalent to each other because 6 plus 15 is the same thing as, 6 plus 15 is 21. Whoops. Where did I go wrong? 6 plus 15 is 21. That would be that's a 7. I was multiplying. I'm sorry. That'd be a 7. And 3 times 7 is 21. So again, that proves that those are the same. Here, 2 plus 5 plus 2 plus 5 plus 2 plus 5. We have the same thing written over and over again 3 times. So this is the same thing as 3 times 2 plus 5. It's the same thing, different meaning. Different look, I should say. And then the last one, rewrite the expression, and let's see. Do we see anything that any of them have in common? Well, I see that this term and this term both have a 2 in common. So I'm going to first write them together. Because remember, you can change the order. Changing the order, the commutative property, doesn't change the outcome. So if we change the order, that helps us see that these two have a 2 in common. And 2 times what would give me 2 times 2? 2. 2 times what would give me 2 times 5? 5. Then if I bring down this part here, notice I have 2 times 5s, and I have I have 2 plus 5s, and another 2 plus 5, because remember we can change that order and it's okay. That gives me an answer of 3 2 plus 5s. You can try the next ones by yourself. These two terms have a 3 in common. So if you pull that out, 3 times what gives me x times 3? X. 3 times what gives me 5 times 3? 5. Notice here, the terms are repeated. Repeated addition is the same thing as what we did a minute ago. So if we pull, how many times were they added? 3. What was added 3 times? X plus 5. Again, it gives us the same thing. And then let's do letter F. 2 times x plus 5 plus x plus 5 times 2. The same thing as what we did the step ahead. If you reorganize them and you change the order, since both of these have a times 2 in it, 2 times x plus 5 times 2 plus 5 plus x, you see that these two terms both have a 2 that we can pull out. 2 times what gives me 2x? X. 2 times what gives me 5 times 2? 5. And then this part we can just bring straight down. Again, if you want to change the order to see what they have in common, you can. The commutative property. So 2x plus 5s plus another x plus 5 gives me 3x plus 5s. And lastly, what if we have different variables in there? It's the same thing. What do these two terms have in common? A 3. 3 times what gives me x times 3? 3 times x gives me x times 3. 3 times what gives me y times 3? 3 times y gives me y times 3. Letter H, I have 3 of the same terms being added together. So that's 3. What did we add together 3 times? X plus y. And then our last one, 2x, 2y. If we rewrite those, makes it a little easier for us to see. Notice both of those terms have a 2 in common. So 2 times what gives me 2x? 2 times x gives me 2x. 2 times what gives me 2y? 2 times y gives me 2y. And I can bring this part down. And then I'll switch that order. And notice I have an x plus y and an x plus y. So altogether we have 3 x plus y's.